Imagine a world where Earth looked totally different. Every continent you know, Asia, Africa, North and South America, Australia, once belonged to a single giant landmass, a supercontinent so massive it ruled the planet. This was Pangaea. You might remember that name from science class, but Pangaea wasn't the first, and it won't be the last. Long before it, other supercontinents came and went, shaping Earth's surface, climate, and the very story of life. Let's take a wild ride through deep time to explore Pangaea, earlier supercontinents like Rodinia, and how these epic landmasses built the world we live in today. First up, Pangaea, the rock star of supercontinents. Around 300 million years ago, it was like a giant puzzle, with all today's continents jammed together. North America was snuggled up to both Europe and Africa. South America was cozy with Africa. This wasn't some random mashup. Earth's crust is made of tectonic plates, huge slabs of rock floating on a semi-molten layer below. These plates creep along, moving as slow as your fingernails grow. Over millions of years, their slow grind pulled the continents together to form Pangaea. Life on Pangaea was intense. Most of the land was one big continent, so the interior was a blazing desert, far from the cooling oceans. But the coasts? Lush forests packed with early reptiles and dinosaur ancestors. The oceans, meanwhile, were one massive body of water called Pangaea. Pangaea's size changed everything: weather, ocean currents, even how species spread. Here's the wild part. Pangaea didn't last forever. About 175 million years ago, it started to split. Tectonic plates shifted, cracking the supercontinent apart. Those pieces drifted, becoming the continents we know today. That's why you find fossils of the same creature, like the reptile Mesosaurus, in both South America and Africa. They didn't swim the Atlantic. They lived when those lands were neighbors. Now let's rewind way further, to a time before Pangaea. Meet Rodinia, a supercontinent that existed from about 1.1 billion to 750 million years ago. Its name comes from a Russian word for motherland, and it fits. Rodinia was one of the earliest supercontinents we know about. Scientists piece its story together from ancient rocks and magnetic clues locked in stone. We don't know its exact shape, but it was likely a huge landmass near the equator, with chunks like North America, Australia, and Antarctica squished together. Rodinia formed when tectonic plates smashed into each other, crumpling Earth's crust into massive mountain ranges. These collisions, called orogenies, were like super slow car crashes that took millions of years. The Grenville orogeny was a big one, helping stitch Rodinia together. But like Pangaea, Rodinia wasn't forever. When plates pulled apart, it broke up, creating new oceans and scattering its pieces across the globe. Rodinia's story is cool because it shaped early life. Back then, life was mostly single-celled critters floating in the oceans. But when Rodinia split, it might have triggered huge climate changes, like the snowball Earth events when the planet was covered in ice. Those brutal conditions could have forced early life to adapt, paving the way for complex creatures millions of years later. Even before Rodinia, there were probably other supercontinents, though the clues get fuzzier the further back we go. Take Colombia, also called Nuna, which hung out from about 1.8 to 1.5 billion years ago. It was another tectonic masterpiece, knitting together ancient lands like Laurentia, the core of North America, and Baltica, parts of Europe. Like the others, Colombia formed, chilled for a bit, then broke apart, its pieces drifting to form new lands. Why do supercontinents keep forming and splitting? It's all part of Earth's big cycle, driven by plate tectonics. Picture a cosmic conveyor belt. Plates collide, building supercontinents. They pull apart, tearing them down. This supercontinent cycle takes about 300 to 500 million years. Scientists even think that in roughly 250 million years, the continents will smash together again to form a new supercontinent. sometimes called Pangaea Ultima. Supercontinents don't just change Earth's surface, they rewrite its history. Colliding continents create mountains that mess with weather patterns. Splitting continents form new oceans, shifting how heat and nutrients move. These changes ripple through ecosystems, pushing evolution in new directions. Pangaea's huge deserts likely gave reptiles an edge over amphibians, setting up the dinosaur era. Rodinia's breakup might have kick-started the diversity of early life. Every supercontinent leaves a legacy. Today, it's easy to see the continents as fixed, but they're not. They're still moving, carrying us along. The Atlantic Ocean grows about an inch wider each year. The Pacific is shrinking. In millions of years, Earth will look as strange to us as Pangaea does now. Next time you check out a map, think of the continents as puzzle pieces, solved and scrambled over and over. Pangaea, Rodinia, Columbia, they're chapters in Earth's epic tale, each shaping the planet in ways we're still figuring out. From brutal deserts to frozen oceans, from tiny cells to vast ecosystems, supercontinents are the architects of our world. The story's still being written. If you loved diving into Earth's wild history, hit that like button and subscribe for more epic science stories. Drop a comment below. What supercontinent do you think is the coolest? Let's keep exploring the planet's past together.